Hi, everyone. Thank you for joining us for today's webinar, Collaborating with Developers, How-To Guide for Test Engineers, with Senior Architect Gil Tayar. If I'll talk about all the amazing things Gil has accomplished in his career, it will take the entire hour, and we don't want that. So I will just give you the highlights. Gil is a senior architect and evangelist at Applitools. He has over 30 years of experience with software development. In the past, he has co-founded Web College and worked on various large projects at Wix. His current passion is figuring out how to test software, a passion which he has turned into his main job as evangelist and senior architect as Applitools. In addition, Gil is a sought-after public speaker and he frequently talks at notable international conferences about test automation and software development, conferences such as Selenium Conf, Star West, STPCon, just to name a few. And to top it all off, Gil is also a faculty member at Test Automation University. And later this year, you will be able to take his course about visual validation for front-end developers with Storybook and Cypress. I think that now it's best to let him speak. So Gil, take it away.
Thank you, Adi. Hi, everyone. There we go. I can start. So, successfully collaborating with developers, a guide for QA pros and test engineers. I think we've covered the about me. I do want to stress two things which are important to this talk. First of all, I'm a software developer, and testing the code I write is a passion of mine. So I've been testing everything I write, and on that front, I want to talk about how developers, and specifically front-end developers, write tests when they write tests, and how we can collaborate with them, understand their language, understand the terminology, understand the methodology by which they write the tests, and maybe even educate those developers that don't test. So, first of all, why? Why stepping in and collaborating with developers? That's the first part. Why is that important? And the second thing is, okay, now that we understand why it's important, how do we do that? How do we work with the developers to write tests? Let's start with the why. Oh, agility. I'm not very fond of the word. It's been abused too much, and I'll talk about how it's been abused in the next few slides, and why I'm not fond. But I'm a huge fan of the methodology, of the practice. I wouldn't call it methodology. Let's start with the basics. The Agile Manifesto. The Agile Manifesto is a one-page, agilemanifesto.org. It's a one-pager which talks about 4 things. It doesn't talk about Scrum. It doesn't talk about Kanban. It just talks about 4 principles. Individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. You can call it the Agile Manifesto. I call it the just wing it approach. The just wing it approach is, for me, the essence of Agile. It's not planning. It's not writing huge tons of documentation. It's just working with the customer in an iterative fashion to generate the software. And I can already see managers saying, oh, no. Just wing it doesn't sound like a good approach to me. We like our plans, we like our processes, we like our documentation. And Agile is saying exactly the opposite. And I would like to stress 2 of the points in the just wing it approach and in the Agile Manifesto. First of all, responding to change over following a plan is, for me, the most important part of Agile. It's saying we can't build a 6-month plan because in 6 months we don't know where we want to be anymore. The internet and the world is changing very, very rapidly, and it's better to do small incremental changes which will lead us who knows where, according to the customer's wishes, rather than planning ahead and doing that. And that's very important. The incremental change and the rapid evolution of the software is the raison d'être, the reason for agility. And I think the most important part of the how of agility is the second principle: working software over comprehensive documentation. Working software means that from the get-go, a month after the get-go, you already have something that is working. It's really, really basic. Maybe it's not fully spec'd, but it's something that the customer can look at and figure out, this is what I want with changes, or no, we're doing something wrong here. I know I said that I want that, but now that I see it, I want something else. The idea is that the software is always working, and it's not like 3 months and then we get something and then another 3 months. And that's the most important thing, and it is the reason for testing, because working software that is constantly working and constantly improving basically means that we can't have not sprints, because sprints are fine, but we can't have these 3 months, 2 months, even 1 month lengthy cycle where the software isn't working. We need to work with what is called trunk-based development. A developer constantly writes code, adds a feature, and pushes it to the trunk, to the master Git branch. There are no long living branches of like 3 months where we do lots of changes, and then only after 3 months the customer can see it. So trunk-based development is, for me, at the heart of the Agile Manifesto. Always, every commit must be working software. Every push to the Git repository must be working software. The software must always be working, and we can't wait. There is no integration time. In essence, Agile says, realize the truth. There is no release. There is no specific point in time where we're saying this is when it needs to be released. The software, according to the Agile Manifesto, can be released at any point in time. It may not have all the features that we wanted, but it can be released. There is no deadline waiting. And I have to admit, as somebody who's been working in the past like 15 years, probably maybe even more, in an Agile methodology, it's very, very less stressful than those big days when I had to, there was a deadline and we had that month of integration where everybody's changes were integrated, and QA and the developers were like working frantically around the clock to ensure that everything is working. No, here we have lots of small incremental changes constantly working. But that's a problem, because we don't have integration time, but we don't have testing time in such an environment. What do we do? How do we test? And there are multiple answers. First of all, the best thing to do is no more nightlies. Tests should not run overnight. They should not take hours. They should not take tens of minutes even. At most a few minutes, 1 to 3 is the best, which is, crazy if you think of regular QA. And how do you do that? How do you get to a situation where every commit is basically tested? And the answer is, we've heard about it. The developers must must test. The developers must write tests that ensure that the software they're pushing to the Git repository is working software. It doesn't mean that we don't need QA. We definitely do, but the baseline that QA is getting is a baseline that is basically working. QA starts with basically working software and progresses to really, really good software, and not QA starting with this software isn't working at all and progressing towards, now it's working. The QA gateway, the most, where if the QA says it can't be released and it's not released, that kind of a gateway where we give the approval, it must stop, it must die. QA is a way of improving the quality of something that is already working. That's great. QA should always be a refinement, an iteration over development. It should be input, but it all should be over working software. That means that the tests themselves, both development tests and the QA tests, must be part of the development cycle. And if we talk about the development tests, which the developer must run before committing the code, before pushing the code to Git, those tests must be fast. Developers cannot wait. They need to know now before pushing, or at least 5 minutes after pushing, that the code runs, and if it fails, where. They have to commit now. We all know the waterfall method: design, implement, test, deploy. This isn't working anymore. What we have in the Agile Manifesto is lots and lots of little design, implement, test, deploy branches or works. Lots of developers, each working in parallel on a feature, where each feature is design, implement, test, deploy, design, implement, test, deploy. Sometimes these little cycles are have 5 or 6 of them before the feature is fully there. But that's great. But if we have a cycle where we implement and then QA test and we implement and then QA test, that's a bottleneck. The better is implement test as part of the same development and implementation process. And this is the essence for me as a developer that worked with QA, that worked with Agile process. This is the essence of shift left. And yay, we have to say that whenever we say Agile, we have to say shift left. But I think shift left is a real thing. It means putting the tests where they should be. Developers can write tests. For example, my canonical example is validating email. To check that the validate email code works, a developer only needs to write unit tests that run in about 1 millisecond, all the validations. For the same tests to be checked by a QA automation expert, we're talking, tens of seconds, if not more, just to check that the email validation is correct. So shift left is important. Put the tests where they make sense. If they make sense at the developer side, put them there. If they make sense at the tester side, put them there. Unfortunately, and that's a big unfortunately, developers do not test, most of them. And for me, that's a pain, because I don't do TDD, test-driven development, where you write the tests before you write the code, but I do write tests immediately after writing the code and use the test to check that the code that I've written is the correct code. I even have a rule which a lot of people are slowly adopting, and as a backend developer, I can do that, which is never ever run the application locally on my machine, except as part of test code. So if I want to write a feature, I write the feature. Now, if I want to see that it works correctly, I can do it only one way: write tests. And that forces me to write tests for that feature, to write enough tests to make me comfortable in pushing to Git and in deploying that feature. Unfortunately, most developers don't work that way. What they do is they write the code, just like all the other developers, and then they have this environment, local environment, where they run the database or whatever else they need, and then they run the application and manually check it to ensure that it's okay. Fine, but we all know that most developers won't do regression testing. They just won't they'll check the specific feature, and if they break anything else, or if they check that specific feature but don't check everything and something fails there, then QA will get breaking software, and the whole cycle of QA coming back and developers fixing that test takes a lot of time, a lot of energy, a lot of bottlenecks, and, well, yeah, a lot of money. But why don't developers test? Well, one answer is it's not we're lazy bums, which is true. Everybody's lazy in their own way, and developers are lazy too. Um, they just wing it. Hey, it worked for my father and it worked for his father or her mother. Why shouldn't it work for me? And and the third one is the basic optimism of every human. Don't worry, it's going to be all right. I call it the ostrich in the sand um, syndrome. So developers don't test because it's easy, basically because it's easier not to write tests. And there's always QA. And I want to talk about the difference between backend and frontend, because there is a difference here between backend and frontend developers. Backend developers test more. I put this picture because backend, they're usually it's much more mature technology. They had more years building methodologies for backend development. Also, it's much easier writing backend tests than writing front-end tests. Usually the backend code is just a web app. And all you need to do is do API testing. HTTP, the server, send something back, and check that the correct response returns. It's pretty easy. I'm exaggerating a bit, but in essence, that's what you need to do. So it's easier, the technologies are more mature, and the methodologies of writing backend software and writing tests for backend software are more mature. Front-end developers test much less. First of all, it's a young discipline. We'll see that in a second. It's a young discipline. Front-end development is not something that's been happening for a lot, especially the modern front-end development, and we'll talk about that in a second. And it's much more difficult to test front-end code. Front-end code is code that a user sees, and the user clicks, and the user navigates, and all that interaction needs to be tested, and it's not just a request-response type of a test. Front-end testing is young, as I said. Actually, front-end testing, and specifically web testing, web app testing, but not only, it goes through a 5-year cycle of invention because it's so young, because things haven't matured enough, and because the browsers themselves and HTML itself has matured. The whole stack that front-end developers use today, and I'm talking Webpack and Babel and Node and all that stack didn't exist 5 years ago. It just didn't exist. React, Angular, these kind of things. I checked. I went looking. React is about 5 years old. And not only that, the previous stack, which we had before, which is Ember, Angular JS, jQuery, Vanilla JS, it was impossible to test. Basically impossible to test. The current task is testable, but as I said, it existed 5 years ago. It didn't exist, so it's taking time to solidify. That's the bad news. The good news is that it has solidified. We now know how to test. We now know what methodology to use for front-end testing. Obviously, there are schools in that, the Kent Dodds school, the Shai Resnick school, the diamond of testing, the pyramid of testing. There are lots of schools around that, but in general, there's a very big agreement on how to do front-end testing. And what we'll see in this webinar is exactly that, how front-end developers test and how front-end developers should test. We're really going to look at code that does this. Okay, so there is a methodology. We can do front-end testing, except that most developers still don't know how. The knowledge hasn't been promoted enough. But why am I talking front-end developers? What about back-end? And the answer is, a lot of time you want to work with the front-end developers because they're closest to the product. Not only that, the code is less tested, we need to help them. As QAs, people, as testers, our job is not only to test the project, but it's to educate the whole company in how to help them test. Just like the DevOps culture is not we're gonna automate the ops, but we're gonna instill a DevOps culture in all the companies so that everybody will be doing operations. And well, it's the best bang for the buck. It's the same tools, basically the same tools that you are using for automation, test automation, and browser automation. Plus, they're much, much cooler. They do HTML, they do CSS, they do graphic design. Usually they're a little bit cooler than the backend people. I'm a backend developer, so I'm allowed to say that. Which brings us, we talked about the why. The why is front-end developers don't test, front-end developers should test, front-end developers should test, and developers in general should test, because that's the only way to do agile correctly and not go into like these processes and month-long release cycles. But the big question is, okay, now that we know that, how do we test? How do we do front-end testing? I will talk specifically about front-end testing. Back-end testing, it has been talked about a lot in webinars, blog posts, conference talks, etc. It's basically API testing, what is called API testing in the tester world. It's just raising up the server in some kind of a staging environment, or locally, if we're talking about a continuous integration environment, or locally on the developer machine, running the server and just HTTPing the APIs and checking that the response is okay. But how do we do front-end testing? Let's start with the language. Get used to it. You're gonna, front-end testers have only one language, basically. It's JavaScript. They may be proficient with Python, they may be proficient with Ruby, they may know a little bit about Java or C#, but 99.9% of their time, they are using JavaScript. And there's this weird, especially with Java snobs, sorry about that, JavaScript isn't a serious language. JavaScript is a toy language, and it shouldn't be taken seriously. It's fine for small programs, but once you get to scale and once you have lots of tests, forget about it. Oh, and 0.2 plus 0.1 is this really, really strange number. That's always, people always give that example as a reason that JavaScript is a toy language. The first 3 points were true. It was a toy language. It could not be taken seriously. It was a toy language 5 to 10 years ago. It's definitely not true now. About the last point, it irks me a lot. It's true in JavaScript, just like it's true in Java, it's true in Python, and it's true in C#. It's not a JavaScript thing. It's the way numbers are represented in memory. It's called IEEE 754, I think. It's true for all languages. And I have 2 quotes for you about JavaScript, and I have to admit very is my favorite language. So a little bit of fanboy will come at you. First of all, this is a very famous slide by Brendan Eich. Brendan Eich invented JavaScript back in '95. Always bet on JavaScript. They said they couldn't do this. They said they couldn't. JavaScript couldn't do that. But in the end, JavaScript today can do anything from regular web apps to games, multi-user graphical, multi-graphic games. And the second one is my famous one, Atwood's Law. If it can be written in JavaScript, it probably will be written in JavaScript. And a lot of things that people didn't believe could be written in JavaScript today are written in JavaScript. And let's give some examples of things that people wouldn't have thought. Gmail, maybe the most important JavaScript app ever. It symbolizes the revolution in how we view web apps. Google Maps, the Twitter UI, Facebook. Large parts of Netflix are written in JavaScript, the server side even. I have tons of examples. My favorite example is a hardware emulator that boots Linux. So you can go into the browser, boot Linux and just, CD your way to whatever you want. And it's the whole thing is a CPU emulator and a hardware emulator that runs in JavaScript and not in any other language. So yes, JavaScript can be written for serious applications and is used for serious applications. It's not a toy language anymore. And JavaScript it's not only that, there's a huge renaissance in JavaScript. JavaScript today is it's powerful, it's concise, it's functional, definitely readable. I read all the time. It's ubiquitous. We have it in the browser. We have it in the server today. Node.js is it's a JavaScript server framework. We run CLIs using it, and it's even on the Internet of Things. A lot of gadgets and whatever run JavaScript inside it. And today, NPM, which is the third-party library that JavaScript uses, is the richest and largest library in the world. It passed the Java third-party library, which is Maven. It's passed it, and it's like 2 times as big today, and it's continuously evolving. Okay, next thing, testing methodology. The testing pyramid. I've seen many versions of that, so I'll be talking about my version. When a developer thinks about testing, they think about unit, integration, and end-to-end, and I'll explain each one. Unit tests test one class, sometimes 2, but basically one class. They are very, very fast. I'm talking a millisecond per test, even less, sometimes a little bit more. They are not flaky. They will always run. And if they succeed, they will always succeed. And if they fail, they will always fail. Because they don't use any I/O, and because we're talking about front-end testing, they're not using any browser features. They're pure business logic. Unfortunately, unit tests bring little confidence. Even if you test all the units, you don't know that they work together. So yeah, you've got a lot of confidence in little pieces of code, but you actually don't know that your application is running at all. But they are very, very important. Integration is when you take a lot of classes or a few classes and run them together as they are in the software and test them as a single unit. Sometimes integration means another thing. It means testing your code for I/O. In the front-end world, it's a JavaScript code that does API calls to the server or uses some browser features. They're still fast, 10 to 100 milliseconds, mostly not flaky. 1 in a million fails, but mostly they do I/O and they use browser features, and they test a group of modules as they are tested in the final product. And for me, those are the most important tests. I do most of my tests as integration tests because they bring a lot of confidence in that the application is actually working. And they're perfect for testing whole parts of the application. Last one is end-to-end. End-to-end are slow, seconds, sometimes tens of seconds. They are flakier. Yes, unfortunately, when you and they're basically browser automation tests. You run the browser and you test your UI through the browser, and that is why they are flaky, because browsers, unfortunately, are big beasts and sometimes fail for various indeterminate reasons. Who knows? And the nice thing about that, they bring a lot of confidence and they test the features end to end. But because they are slow, because they are flakier, they are at the tip of the pyramid. Well, developers don't write a lot of them. They prefer having 5, 6, 10 of those tests, ensuring that the happy paths of the main flows of the user are working, and we're good with that. So the more we go up, the more confidence we have. Unit, not a lot of confidence, integration much more, and end-to-end, lots of confidence. But unfortunately, a side effect of those is the test becomes slower and flakier. And there's a big discussion on how many integration, how many unit, and how many end-to-end. There are 2 schools. The pyramid school, which says a lot of units, not a lot of integration and the diamond school, which I'm part of, which says not a lot of units, a lot of integration, and not a lot of end-to-end. Which one would you like? Well, I'm a fan of the diamond, but you know, some of my best friends use testing pyramids. Okay, shift left. Okay, but what's the tester's role? As we said, we educate and monitor. Don't forget, we are lazy bums. Work on the tests with the front-end developers and write the real end-to-end tests, preferably using the same JavaScript and browser tools as the developer, so the developer can add that. And for me also, write end-to-end tests that run on production so that you can test the real environment, assuming that you are in production as a software as a service. Okay, we've talked a lot. We want to see some code. How do I write the tests? Let's see some code. We'll go through unit, we'll go through integration, and we'll go through end-to-end. And we'll start at the bottom because the bottom is easiest, writing an integration. Remember, unit tests only one module or a function, or if you're an OOP kind of a person and in a class. They bring little confidence of their own, but are perfect for business logic testing and are very fast, milliseconds. Okay, canonical test is testing factorial. This is a JavaScript code for factorial. Function factorial, there's a loop that multiplies result with 1, 2, 3, 4 till we get to n, and then we return the result. That's great. And we have that last really weird line, which is saying, and this is JavaScript-ish, factorial is what the module exports. Modulo exports equals factorial. This is the function that is exported by this file. If there were other functions, they are internal to this file and are not exported. You may see something in JavaScript, which is export default factorial, same. And who uses the function just requires that file, factorial.js, and then just uses it as a regular function. Instead of require, you may see import factorial from factorial.js, same. And what do we want to test? Well, we know how to test factorial. Factorial of 0, we want to test that it's 1. Factorial 1 is 1, etc. Standard testing. So how do we do that? We can write a file. Test factorial.js. We import the factorial code because it's just function, and we assert that factorial 0 is 1, we assert that factorial 1 is 1, and we assert that factorial 5 is 120. And assert is a regular module in Node.js that enables us to assert and fails if they're not equal. Very simple. But wait, what is this talk about browser? About Node.js. We're not running server-side. This is front-end code. We're running client-side. We wanted this code to run on the browser, no? But unfortunately, the browser supports very basic. There are no modules in the browser. You can't export a function. You can't import a module. That it's not available in browsers today. Fortunately, there is a way around that, because if you think about it, writing a whole application, hundreds of thousands of lines of code in one big JavaScript file is not feasible. It's basically impossible. It's impossible. So what we do is we take those lots of files which import and export lots of stuff, and we pass them through a tool called Webpack. Most people use Webpack. It's called a bundler. What it does is it takes all that production code, which requires it takes all those modules, all those files, and bundles them into one big long file, which we can script source in our HTML. So the developers can develop using modules, using packages with separate files, but Webpack will bundle them together in one. Can this code, after bundling, so we've seen that the code which imports and exports JavaScript can run in the browser with the help of Webpack. But the nice thing about it is that the same code runs in Node.js. Exactly the same code can run in Node.js. So And that's beautiful, because today, which was not true like 5 or 10 years ago, most front-end code can run in the browser. Obviously, it has to run in the browser, but it can also run under Node.js. This kind of code, which can run under both environments, is called universal or isomorphic code. Let's run it under Node.js. Remember the test factorial? We run it using Node in the command line. We give it the file testfactorial.js, and the test passes. Yay, we're good. Remember the code that asserts that factorial 0 is 1, etc., etc. We run it under Node and it works. But it's very awkward to, write tests like this, not this one, this one. It's not fun. It doesn't scale. So what we need is a test runner. Just like Java has JUnit and TestNG, and C# has their own NUnit, I think. PyTest for Python, etc., etc. Node.js has lots of them. Mocha, Jest, Ava, Tape, Jasmine, there are more. This goes on. The most popular today, by far, are the two big ones, Mocha and the newcomer called Jest, which is written by Facebook. I'll be demoing using Mocha. It's the one I prefer, but please go ahead and use Jest. It's a wonderful, wonderful tool. And if you want others for some various reasons, they're great too. And this is a Mocha test. First of all, on the left side, we require Mocha. We import Mocha, and we import Chai, which is the validation library, where we can assert stuff, assertion library. And then we import the function factorial. Now we write the code, we describe factorial, and we write tests. Each test is an it. It should handle 0. And in the function there, that arrow thing is an arrow function. We say expect factorial 0 to equal 1, expect factorial 1 to equal 1, etc., etc. Expect factorial 5 to equal 120. That's it. Very similar to other test framework, test runners. If you're familiar with TestNG, JUnit, well, not exactly. It's not no classes, it's all functions, but in the end, it's basically the same. Let's run it under Mocha. I run Mocha with npx. I don't want to get into the technicalities, and I give it the file, and boom, the test passed. Yep. And it's important now that we've understood unit tests. It's important. We need to, and as much as I don't think we need a lot of unit tests, we should move as much code as we want into units that do only business logic. We need to separate the UI code and the IO code from the logic and test the logic unit tests. That is very important. So, for example, this is untestable code. A write factorial to server, which computes the factorial and then does a fetch. A fetch is an API call to the server and sends the factorial to the server. That is not good, because now just to test the factorial, I have to raise the backend server and do lots of stuff. I would prefer extracting that factorial into a factorial function, which I can check easily, as we've seen. And notice how important speed is. 9 milliseconds for four tests. That's basically 2 milliseconds per test. If we had hundreds of tests, that would have been far less than 2 seconds, because JavaScript takes a little bit of time to warm up. So after a couple of seconds, we'll be getting sub-millisecond times for each test. Write integration tests. Now we've seen unit tests. How do we write integration tests? Remember, we test a group of modules that are glued together. We do I/O and use browser features. They're still fast, and they're mostly not flaky. And the important thing is that we use browser features. So must integration tests run in the browser? And the answer is, incredibly enough, no. Those tests can and should run under Node.js in what I call a simulation of the browser. Unfortunately, time is short. I can't really show you that. It's a whole talk unto itself. You can see this YouTube video. It's a talk about integration tests in Node.js. Don't worry, there will be a recording, so you can take that, and we will also send the the slides themselves. So if you're interested, just a taste. What we do is in the before all the tests run, we create what is called a JS DOM. A JS DOM is a virtual implementation of the DOM. It's an implementation of a browser, if you want, in Node.js. And we set the global variable window and global variable document to that DOM. So now we have a global variable window and a global variable document. So in essence, Node.js is behaving like a browser. But it's not a browser. It doesn't, you can't view anything. It just behaves like a browser. So now if I'm, and this is a little bit of React code, now if I take some of my React code and just run it in the test, it passes. It works. I can do document.query selector. I can run React code. I can run my app code. My app code is running thinking it's running in the browser, but it's not really. And I can click on things and type into things and do all those kinds of things, but it's running under Node.js. And those tests are crazy fast. They run in milliseconds. They don't need to run a server, no need to run a browser. They're not flaky. You can debug them with any of the excellent Node.js debuggers we have. No source maps, no build steps. Oh, there's a lot of positive advantages to them. And if we run it, they work. I don't want to get into it. What about end-to-end tests? Last but not least, the tip of the iceberg is end-to-end tests. We need a browser automation framework, and we have lots of them. Selenium WebDriver, WebDriver.io, Cypress, Puppeteer, Test Cafe. The list goes on and on and on. There, I think of as JavaScript has the most browser automation frameworks of all the languages. We'll be using Selenium WebDriver. Most of you, if you know a browser automation framework, are probably using Selenium WebDriver. My personal preference today is Cypress, and I'm building a course in test automation U on that. So let's write it. First of all, we need to serve the front-end code. We're running a browser now, so we need to have a web server that serves the front-end code. This is like 4 lines of JavaScript. I don't want to get into that. It really is 4 lines of JavaScript just to serve the front-end code. We initialize WebDriver. Say new WebDriver.builder. We say for browser Chrome. We don't need to run any Selenium server, nothing like that. JavaScript handles that perfectly by itself. And in the after all the tests, we do a driver.quit. And then the test itself, driver.get, which is the Selenium for navigating to a specific page. Notice the await, because JavaScript is an asynchronous language. We need to wait for the driver.get to happen. Anything that concerns I/O needs to have an await before it. I don't want to get into the specifics. It's a great talk unto itself. But in the Applitools blog, you have a blog exactly about async await code in Selenium WebDriver tests. And then we find the elements, the whatever, click on them, and then ensure that the element text is whatever it is. And finally, if you think about it, the backend developers don't care how the application looks like, but front-end developers do. It's especially important for front-end developers to check that their application is still looking the same, and any changes that they did to the HTML and CSS haven't made the application look bad. It enables the front-end developers to ensure that their application always looks the same. Well, it's pretty simple to implement a top automation test. It's just a 1 line. I'm using eyes here, Applitools eyes. Just check window and we're done. You've added visual regression testing to the whole thing. So, in summary, Agile is here. There is no release. Code should always be working. The QA gateway method, integration time, testing time cannot work anymore. We need to shift the left to testing during development. We need to work with developers for this, mostly front-end developers. And to do that, we need to understand the language of the front-end developers. They're talking about unit, integration, and end-to-end, and we need to understand what they mean in each of these things. Unit tests business logic, no I/O. Integration tests check large parts of the code, but with a simulation of the browser and running under Node.js. And Endtoend is a real browser automation test. It's a whole new world out there, so really, it takes time to learn, but I think it is worthwhile, both for front-end developers and for you. And if you need lots of resources, you have a intro to front-end testing. You have a Cert.js Talks. It's a really great conference about front-end development and testing. And people to follow. Kent C. Dodds is great. He's the #1 testing, front-end testing person out there. Kevin Lambing is great. He wrote WebDriver IO. And yeah, I have some talks, blog posts, tweets, etc. So feel free to follow me too. Thank you very much.
So we're going to take a few questions now.
Yep.
Yeah.
I'm ready.
Okay, so just a moment before we go to questions, I just wanted to mention something. You mentioned a lot of great names, and a lot of them will be speaking at Automation Guild Conference, the online conference dedicated to test automation excellence that kicks off on February 4th. So over 20 industry experts, including Angie Jones and Jonathan Lips and Kent C. Dodds and Corinna Pipp, will talk about topics that are near and dear to, I think, everyone's hearts and work, and at least anyone that attended this webinar. And they're going to talk about test design, AI and test automation, mobile testing, Jest, IntelliJ, a lot more. You can have a 20% discount when you sign up, and I put all the information in the chat room in the GoToWebinar control panel, so you can find all the information there while we take questions. So feel free to copy, click, link, and if you have any questions about that, just contact me in the questions panel, and I'll answer you privately. So with that said, let's go into some questions. The first one, I think, is how do you see the role of the tester evolve? What will be his role, or what will he be testing if most of the testing is moving to the developers?
That's a great question, and it's one I've been pondering a lot, but I'm seeing it. Once it's basically what it should have been all the time. If the baseline the developers are giving when they're throwing over the wall is bad, then the tester's role was to make it, not so horrible. Which is what was happening back in the days when developers, what is happening when developers don't test. It's making bad software passable. Once developers start testing, the code, the test now, the product is now passable. You're getting, the baseline is workable software. Now the tester's role is making it from passable to great software. It's looking at a higher level, looking at the flows, whether they make sense, looking at the really interesting bugs that happen when things go to scale and not, when one user or two users run them. The more interesting stuff starts to bubble up, so that QA's role is back to where it was, ensure quality and not barely working software. And I think there is a huge role there. One, I think testing in production is, for me, the shift right is incredibly important. Let's test it on the real, with automation, on the real environment, and not on a simulation that barely taxes the servers, but on real environment where crazy things happen. That's one thing. And the other is looking at the software from a UX perspective, from a flow perspective, from a requirement perspective, from a product perspective, and seeing not that it's passable and that it works, but that it's great. So, yep, that's where I think testers' roles should be and are in a lot of places.
So follow-up questions on that. You don't see the QA role and the developer merge and become one?
That's a question. I think it depends on the company. It really depends on the company. It depends on the philosophy of the company. Will the roles merge? I don't know. I used to think that yes. Today, less so. I think there is a huge role for QA as QA. Testers, developers will always create passable software. They don't have time for the higher level view. They don't have time to test in production. There is a place for QA as QA. Will their roles be intertwined? Definitely. I hope so, and it's happening in some of the companies I've worked for.
Okay. By the way, I just wanted to mention something. I see a lot of people asking for the links that Gil has on this slide. So I just wanted to make sure that please rest easy. Those links, along with Gil's slide deck and the full recording, will be emailed to you by end of day Friday. Okay, so don't worry, you will get all the links, the slide deck, the recording, everything will land in your inbox. So please don't worry about that. Next question. Maybe moving on from the roles of QA and developers and talking about what they actually do. So I got a lot of questions about unit testing. A lot of people that are in QA roles were requested to write unit tests. And they didn't know if that was like the right approach or not. And I see a lot of people that are actually debating within themselves if QA should help developers with unit tests. Where do you think? Where do you stand on this issue?
I think it's wrong for QA to write the unit tests, to be the sole writers of the unit tests. It's wrong. Unit tests should be where the code is, and the developers are writing the code. But should they mentor? Should they educate? Should they help? Definitely. Definitely should be there. And to do those three things, they need to understand how to write unit tests. But I don't think having QA be the sole writers of unit tests, that's missing the point. We're back to square one. So helping, educating, assisting, definitely. Writing it as, okay, now QA, go write the tests, wrong, definitely.
Okay, moving on to another topic that was quite popular in the questions, and that was the end-to-end testing. So the first question was, you mentioned when you talked about end-to-end testing that flakiness goes up, but confidence goes up, and people ask how those two live together mutually. How do you have both confidence in the tests if the flakiness goes up?
Interesting. I never thought of that. It's a question of interpretation. When I say confidence goes up, it means that when the tests really fail, I'm ignoring the flakiness, then you know that there's a bug. When all the tests pass, then you know that it's okay. The software is better, is working. So in terms of that, but you are absolutely right. In that the more flakiness you have, the less confidence you have in the results themselves, which is why we need to have as few end-to-end tests as possible. Have the bulk, at least in front end, actually also in back end, the bulk be integration and unit tests. So yeah, true. The more flakiness you have, the less confidence you have. But if you don't have a lot of flakiness because you don't have a lot of tests, then the confidence grows up.
And you mentioned now integration tests. So should those be written by the developers or the QA, or both?
They should be written by developers. Most of the tests I'm talking about here are the tests that are written by the developers. But as I said, developers are lazy. Developers don't understand. Developers don't know. We need to help those developers write those integration tests. And to help them, we need to, at least initially, write those unit integration tests for them, understand how this whole thing works, and then help them set it up so that they can continue the process. If QA writes the integration tests, it's back to throwing over the wall and doing a long release cycle. We're missing the point. It is up to the developers to bring working software to QA so that QA can make working software great software.
And another question that we had about E2E tests. People were, so we got some questions. So are those purely UI tests, or can they include API tests as well?
This seminar is mostly, this webinar, sorry, is talking mostly about front-end developers. So in this case, it's definitely UI automation. And when I think of end-to-end, I think end-to-end, as in the whole system together, front-end and back-end. So yes, for me, it's definitely automation. But when you're testing a huge system, then yes, sometimes you need to skip those UI automations and go directly to the API level. It depends on the size, it depends on the project. For example, my project at Applitools, which is the visual grid, is only a backend project. There is no front end because the front end is the eyes, it's another team. So in my case, my end-to-end test is only API tests. But in a project where both are integrated and both are working together, I think that most end-to-end tests should be UI automation tests and delegate the API tests to integration tests, and or maybe have a few end-to-end tests that are API tests.
So we are out of time. I just wanted to mention that I see, first of all, I see all your thank you notes to Gil. So obviously we won't go through them now, but I do promise you that any note, any personal note that you do write to Gil, I will pass it on to him. And he will receive it. So if you have all your thank you notes are going to make their way to him. First of all, I also wanted to mention something. So just as maybe a wrap-up question for you, Gil, and I know you touched on it before, but I see a lot of people very nervous about job security and QA and testing and test automation and test engineering. Do you have any tips, any best practices, anything that you can tell people either to put them at ease or to give them some tips on how to become very valuable to the organization in their QA role?
I gave a webinar about a month or 2 or 3 months ago about AI, and the conclusion is if you don't want to lose your jobs, you need to think. And I think this is exceptionally important in today's age. If you think about those really big test automation suites, it's rote. It's going after every little specification and writing a test for that. There's not a lot of thinking going on there. If some of those are moved over to developers, and you know, this is a 10-year, 20-year thing. I don't know how long it takes until all developers will test, and if it will ever happen at all. But let's assume it happens, then the time that was spent in rote, simplistic, and not very interesting testing will now be left to do the really interesting tests. We're in the world of machine learning. We're in a world where the product itself is going to be crazy difficult to test. A developer can't really test notifications and machine learning and all the really crazy stuff that's coming out there today. It is up to the QA to do that. The only thing a developer can do is write code, and if they're good, write code that basically works. But basically works isn't good enough. We really need to test that. And to test the more and more complex software that we're getting today, you need to think. And that is always true. And that is true for the future, and never mind which profession, which career you're choosing. The more you think, the less chance, the more security you have in your job.
Great. So with that, I think that we're going to wrap up. So just a few reminders before we do sign off. Automation Guild conference kicking off next week. Just a fantastic conference. Check it out. You have the link in the chat box. And of course, if you decide to register, you have a 20% off. All the information is there. I got a lot of questions about how do you start with software testing and how do you start with test automation. I do strongly recommend that you check out Ministry of Testing for to get a leg up on software testing, and for people that want to really excel in test automation, I do urge you to check out testautomationu.com, Test Automation University. It's our initiative being led by Angie Jones, and it's absolutely fantastic. Later this year, you're going to have a course by Gil Tayar as well. And of course, you can follow Gil on Twitter. His handle is at the bottom left corner of the slide, so you can copy that. Of course, you're going to get all the slides, all the links, and a link to the on-demand recording by end of day Friday, as I promised. So I want to thank everyone that joined us today for this very in-depth session, and of course to thank our speaker Gil Tayar for this great presentation. And have a great rest of your week.